Hi guys, and welcome to lesson 3.5 of Unit 3, Sequence of Transformations. So we're going to look at conducting some transformations followed by another transformation. One of the special ones we have is called a glide reflection. And a glide reflection is the composition of a translation where you slide across a line and then you reflect over it. So you slide and then reflect. So we're going to draw the result of the composition of those isometries. This is an important word, isometries. Isometries means it creates a congruent figure. Our translations, our reflections, and our rotations are all isometries. Dilations are not isometries. They change the size. So now we're taking KLM, triangle KLM, and we're going to rotate it 180 degrees about the origin. So our rule for that is the opposite of x, the opposite of y. So I start with that. I look at the opposite of my x values, and I just start writing those down. And then I have to look at the opposite of y. The opposite of a negative 1 is positive 1, positive 2, positive 4. And then it wants me to reflect across the y-axis. The rule for reflecting across the y-axis is to keep my y, which is my mirror, and flip the sign on my x. So the negative of negative 4 is positive 4. Negative of negative 5 is positive 5. And the negative of negative 1 is positive 1. And then I simply keep the y values from this set of coordinates. I'm not going back to the originals. These are my originals, these are my prime, and these are my prime. And you can see they're labeled as such over here on the drawing. Would the order matter? Could I do the reflection over the y-axis and then do the 180 degree rotation and end up in the same place? Let's mentally think about that. So if I reflected over the y-axis and then I rotated in 180 degrees, I may not. It may be at a different spot. So in general, yes, our order does matter. Okay, so let's look at another one. So we're going to rotate the figure 90 degrees counterclockwise, that's in that direction, about the origin, and then translate using the rule of x plus 1, y plus 2. And then, so we're first going to do the rotation, which is 90 degrees counterclockwise. That should be positive, about the origin. And our rule for that is the opposite of y followed by x. So what I want to do here is I'm going to look at my y coordinates that I was starting with. Opposite of 0 is 0. The opposite of 2 is negative 2, negative 1, and then 0. And then I take my x value I was given and I write it just as it is. Just copy those x values over. That would be my rotation of 90 degrees counterclockwise about the origin. And those are my prime coordinates, my prime A, prime B, prime C, or A prime B, prime C, prime D, prime. Just kind of like Optimus Prime from the Transformers. And then I'm going to translate, that's what the capital T is, I'm going to add 1 to every one of these x values. And then I am going to add 2 to every one of these y values. And those are my prime coordinates, and that's what's graphed over here. This would be, by the way, my rotation rule for 90 degrees clockwise about the origin, capital R for rotation. Remember, it's a lowercase for reflection. 90 degrees about the origin. It's going to take my xy coordinates, and it's going to convert them to the opposite of the y coordinate to be written first, and then my x. And this is how I would graph them. This would be my new x, and that is my new y. So whatever numbers you get in that order, you still graph them just the same. All right, let's take a look at this one. I'm going to reflect across the line y equals x. Reflection is lowercase r across y equals x. The rule is right there in the reflection. It's y then x. And then I'm going to reflect across the y-axis, meaning I keep my mirror the y and I flip my other, which is going to be the x. So I'm going to write the y first and then the x. We'll write the y first and then the x, write the y first and then the x. And then I'm going to do the opposite of the x's. That's these x values, and I'm going to keep the y's. It didn't ask me to graph this one. It just wanted to know what my prime coordinates were. So my L prime is now 4, -3. That's how I would graph it. My M prime is -1, 0. That's how I would graph it. And N prime is 4, 1. That's my new x, my new y. Let's do one last example here. This one I don't even have the graph. I'm just going to follow the rules. I'm going to translate. I'm going to subtract 2 from every x and add 1 to every y. So this is my translation rule, setting it up nicely in a chart. And then I'm going to reflect it across the x-axis, which means I keep my x, which is my mirror, keep the mirror, and I'm going to flip the other one. So when I complete this, I subtract 2 from each of my x coordinates. I add 1 to each of my y coordinates. And then for the final reflection, I'm keeping my x, and I am going to flip the y. Okay, I want you to try these. I want you to pause the video, set up your chart, complete your work, come back, and then you can check. This is what you should have gotten for number 1. Pause the video, check your work, restart. I want you to try number 2. Pause the video, complete your chart, and then come back and check your work. Pause the video so you can read through and check all your work. After you check it, I want you to complete this one. Notice it is a multiple choice question, and it's asking what are the coordinates of the final image of G. So even though they've given you E, F, and G, I would set up a chart just for G. Pause the video and try. Come back and check your work. Pause your video. Give number 4 a try. It is also multiple choice. Set up a chart for just K. Pause your video, try it, check your work, make sure you're good, and we will see you on the next lesson.